Usually when you try to find your place in the universe, you expect absolute coordinates. Classical physics, the physics of Isaac Newton that we all learn in grade school, is built entirely on this giant, unyielding GPS grid.
Right, the absolute background.
Yeah, you ask where you are, you ask how fast you're moving, and the universe provides a definitive, objective latitude, longitude, and velocity. I mean, the map is the territory, right?
Yeah.
And the map is the same for everyone.
It's the ultimate comfort blanket of classical mechanics, really. There is just this single objective reality out there. Like if a tree falls in the forest, it makes an absolute sound.
Regardless of whether a lumberjack is there to hear it.
Exactly. Or a squirrel, or absolutely nobody. It just happens objectively.
Right. And we are fundamentally wired to like things that are fixed like that. But when you step into the bleeding edge of quantum mechanics, that universal GPS completely shatters.
So it really does.
Suddenly, you're looking at a map that is, well, for lack of a better term, entirely relative. It's this navigational nightmare where you ask for directions to the grocery store, and every single person you ask just says, well, turn left at my house.
And the terrifying part is that from the perspective of fundamental physics, every single one of those people is absolutely correct, which is wild to think about.
It is wild, and that's exactly what we are unpacking today for you. This is a massive, mind-bending debate happening right now in the theoretical physics community.
Specifically centering on a framework called Relational Quantum Mechanics, or RQM for short. And within RQM, there is this very specific, incredibly thorny issue known as the combination problem.
So for today's deep dive, we are looking at two highly detailed sources. First, a 2024 paper by Emily Adlam that outlines this whole structural crisis in RQM.
Right, and then a direct, incredibly dense 2025 rebuttal by Timotheus Riedel.
And the hook here, the thing that flips your understanding of reality completely upside down, is that in relational quantum mechanics, reality only exists relative to an observer.
Which sounds a bit like standard quantum theory at first glance.
Yeah, but here's the catch. An observer isn't a human being in a white lab coat taking notes. An observer can be a single electron.
Or if a photon of light.
Right, or a speck of dust. So the mission today, the question we are exploring, is how do billions of these tiny microscopic electron observers somehow combine to create the solid macroscopic reality that you experience every single day?
How does that whole city full of particles giving relative contradictory directions manage to agree on a single coherent map of the universe?
Exactly. I feel like we're in an undergraduate physics seminar today. So to even approach that question, we have to strip away a lot of preconceptions, right?
Oh, absolutely. Before we can even look at how micro-observers combine to form a complex system like you, we need to rigorously define what an observer actually is in this framework.
Because it's not what people think.
Not at all. RQM was originally proposed by the physicist Carlo Rovelli back in the mid-1990s, and it was a radical attempt to solve one of the most stubborn issues in science, which is the quantum measurement problem.
Okay, the measurement problem. That's the classic Schrodinger's cat scenario, right? The idea that quantum systems exist in this blurry state of probabilities, a superposition, until someone or something measures them.
Right, and at that point, the wave function collapses into a single definite reality.
Yeah. But you have to push further than the orthodox Copenhagen interpretation to understand Rovelli's motivation here.
Yeah, because the Copenhagen interpretation relies on this really arbitrary dividing line between the quantum world of probabilities and the classical world of solid facts.
It implies that measurement requires some special, macroscopic, maybe even conscious apparatus to force the universe to make a choice.
Exactly. And Rovelli looked at that and said, well, that's fundamentally unphysical. Why should a measuring device follow different rules than the particles it's measuring?
I mean, because the measuring device is made of the exact same particles. It shouldn't get a magical exemption from the laws of physics just because it's big.
That is exactly the problem. So Rovelli proposed RQM. He argued that quantum states and the outcomes of quantum measurements are not absolute facts about the universe. They are entirely relativized.
Relativized.
Yeah. When two physical systems interact, a relative fact is created between them, and only between them.
Wait, so let me get this straight. If I'm holding a cup of coffee right now in the RQM framework, the coffee cup is observing my hand and my hand is observing the cup. The interaction itself is the observation.
I mean, I wouldn't use the word observing quite so casually there.
Why not?
Because it implies cognition. RQM uses an incredibly thin definition of an observer. There's no consciousness, no agency, no intention required whatsoever.
So a rock can be an observer.
A fundamental particle bumping into another fundamental particle is a measurement. It establishes a physical fact relative to those two specific interacting systems.
Okay, so it completely strips away all the magic. It kind of reminds me of how we treat velocity in classical physics.
How?
Like, if I'm sitting on a moving train reading a book, my speed relative to the seat beneath me is 0. But my speed relative to the train tracks outside is 60 miles per hour.
Right, the frame of reference.
Yeah, neither of those speeds is the absolute truth of the universe.
Right.
There is no absolute speed. Speed is just a property that only exists as a relationship between two systems.
That's a good way to look at it.
So RQM is basically claiming that all physical properties, like a particle's spin or its position or its momentum, are exactly like velocity. They only exist in relation to something else.
That analogy works structurally, yeah. But you really have to recognize how much more extreme RQM is than simple Galilean relativity.
Okay, how much more extreme?
Well, in your train analogy, everyone at least agrees that the train and the tracks exist, right? In RQM, the very state of the particle, whether it's a distinct, localized object or a smeared-out cloud of probabilities, is relative.
Wait, really? The physical state itself is relative?
Yes. There is no absolute spin-up or spin-down floating out there in the void. A particle only acquires the property of spin-up relative to the specific system it just interacted with.
Oh, wow. So to a third system that hasn't interacted with it yet.
That exact same particle is still mathematically and physically in a superposition of states. It hasn't collapsed for that third system.
That is deeply unsettling. Because it removes us, humans, entirely from the center of the universe. I mean, for a century, quantum physics has inadvertently fed this human arrogance, you know?
Oh, the idea that the universe requires a conscious mind to look at it in order to become real?
Exactly. But RQM entirely dismantles that. It tells you, the listener, that you are not special. You follow the exact same quantum rules as a carbon atom floating in interstellar space.
The universe doesn't care that you have a cerebral cortex. It only cares that you are a physical system interacting with another physical system.
It's profoundly democratizing.
It is democratizing, but that democratization immediately plunges us into a structural nightmare.
Combination problem.
Exactly. Because if a single speck of dust is an observer with its own valid relative reality, and you are a macro observer made of billions of these tiny specks of dust, whose reality are you actually experiencing?
Which brings us right to the cliff edge. And this is where Emily Adlam's 2024 paper steps in to sort of push us over.
Yeah, she identifies this precise paradox as the combination problem, and she uses a really striking parallel from the philosophy of mind to illustrate the severity of it.
Panpsychism.
Right, panpsychism. Though I'd be careful leaning too hard on the panpsychism angle because physics and philosophy often borrow each other's vocabulary and just muddy the waters.
Fair enough. But panpsychism is basically the philosophical proposition that consciousness is a fundamental, ubiquitous feature of the physical world, right?
Yeah.
Down to the electron, matter has some rudimentary subjective experience.
Yeah, and Adlam is very clear that RQM's thin observers do not have psyches. A dust mite doesn't have a subjective inner life in this physics framework.
But the architecture of the problem is identical. The core flaw of panpsychism is trying to explain how billions of tiny microscopic consciousnesses somehow stitch themselves together to form the unified macro consciousness of a human being.
Yes, exactly.
And RQM has the exact same homework assignment. It has to explain how billions of micro-observers, each generating their own tiny, isolated relative facts, stitch themselves together to form the unified macro-observer that is you.
You holding your coffee, perceiving a single stable room. Right. So Adlam breaks this massive overarching problem down into two distinct sub-problems to tackle it analytically.
Okay, let's pull those apart. What are they?
She calls them system combination and structure combination.
System combination. So that's essentially the when and the how, right?
Yeah.
Under what specific physical circumstances do a bunch of microscopic observers actually merge to form a new, higher-level macro-observer?
Precisely. Like, does just throwing a bunch of atoms into a box make the box an observer? It's a boundary question. What defines the border of a composite system?
Okay, and then structure combination.
That asks about the physics of the facts themselves. Once you somehow have a macro system, how are its relative facts related to the facts of the microscopic parts that make it up?
Like, do you, the macroscopic human, simply inherit all the relative facts of your individual atoms?
Exactly. If an atom in your left pinky interacts with a photon and measures spin up, and an atom in your right thumb interacts with a different photon and measures spin down.
How does the macro you synthesize those facts without immediately devolving into a contradictory mess?
Right. To really visualize the stakes here, Adlam adapts a classic thought experiment called the zombie argument.
Oh, I love this one.
Yeah.
In philosophy, A philosophical zombie is a being that is physically identical to a human, atom for atom, behaving exactly like a human but with zero inner conscious experience. The lights are on, but nobody's home.
Yeah, and Adlam ports this idea into relational quantum mechanics. She suggests we can mathematically conceive of a universe where all the fundamental microparticles exist, and they're bouncing off each other constantly, generating billions of microscopic relative facts.
But no macro observer ever forms.
Right, it's a universe of pure static. The mere physical proximity of a bunch of particles doesn't mathematically guarantee that a higher-level composite entity emerges from them.
Okay, think of a symphony orchestra. You have 100 musicians sitting in a room. Those are our micro observers.
Okay, I like this analogy.
The violinist plays a C sharp, the flutist plays a G. Every time a musician plays a note, that is an interaction, right? A micro observation creating a relative fact.
Exactly.
But just having 100 people playing random notes in the same room doesn't automatically create a symphony. A symphony is a unified macroscopic phenomenon. It requires structure.
It requires sheet music.
Yes. It requires sheet music to organize those isolated actions into a single entity. So the combination problem is really asking, where is the sheet music for reality?
What forces our atoms to stop acting like a random crowd of microfacts and become the cohesive entity of you experiencing the world? And Adlam's primary, devastating critique of orthodox RQM, the original framework by Riedel, is that it not only lacks the sheet music, but its fundamental axioms actively prevent the orchestra from ever playing together.
Wait, how so? If the particles are constantly bumping into each other, exchanging energy, exchanging momentum, shouldn't they naturally sync up over time?
You're thinking about interactions classically, like billiard balls transferring momentum, but we are talking about the transfer of quantum information and relative facts here.
Okay, so what's the difference in RQM?
In orthodox RQM, there is a very strict foundational rule. All facts are strictly relative to the specific observer involved in the interaction, and there are absolutely no absolute or non-relative facts that systematically connect different observers.
So every observer is trapped in their own little solipsistic bubble of reality.
Yes. If particle A measures particle B, that result is a fact only for particle A.
And if particle C comes along later?
It has no access to the reality that particle A just experienced. If we return to your orchestra, it's not just that they lack sheet music. Every single musician is playing inside a completely soundproof, opaque booth.
Oh, wow. So the violinist literally cannot hear what the flutist is playing. They cannot coordinate.
They cannot coordinate at all. If microscopic observers can never systematically share information or compare their relative facts, Adlam argues they can never dynamically combine to form a complex macro observer.
Because the microfacts are totally isolated, which means any macrofacts you experience would have to be completely autonomous, just floating out there ungrounded from the physics of your atoms.
Which completely defeats the purpose of physics. The whole goal of physics is to explain the macroscopic world through the mechanics of the microscopic world.
Right. If the macro world is just ungrounded magic, the theory has failed.
Exactly. And this isolation leads to a really severe issue known as the problem of the preferred basis. Have you heard of this?
I have, but let's break it down for the listener.
The preferred basis problem is arguably the most difficult hurdle for any interpretation of quantum mechanics to clear, and it hits RQM particularly hard. In quantum mechanics, a system doesn't possess pre-existing defined properties before a measurement occurs.
You force the system to pick a value by measuring it.
Yes. But crucially, you, the observer, have to choose what you are measuring.
You have to pick the question before the universe gives you an answer.
Exactly. For an electron, you can choose to measure its spin along the vertical axis. You're asking the universe, is this electron spin pointing up or down?
Or you can rotate your equipment and measure its spin along the horizontal axis, asking, is the spin pointing left or right?
Right, but Heisenberg's uncertainty principle tells us you cannot know both at the same time. These are incompatible observables. Measuring one destroys the quantum information about the other.
And the axis you choose to measure is called the basis. So what's the problem in orthodox RQM?
The problem is that when a microscopic particle naturally bumps into another particle, there's no conscious scientist there turning a dial to pick an axis. There is no physical law dictating which basis the first particle used to measure the second.
Oh, I see.
The mathematical description of the interaction can be written in multiple, equally valid ways using totally different bases.
Which means if my body is made of billions of particles constantly interacting, some of my atoms might be measuring the universe in a spin-up-down basis.
And the atoms directly next to them might be measuring the exact same universe in a spin left-right basis.
They are gathering totally incompatible, contradictory facts about the exact same physical space.
Yes. If a macro observer is just the sum of its microparts, and you simply inherit the facts of your atoms, you would be a walking contradiction. You would perceive the world in a blur of incompatible variables.
But you, the macroscopic entity listening to this, only ever experience one incredibly coherent, stable reality.
Right.
I never look at a coffee cup and perceive it as being simultaneously in two incompatible physical states.
Exactly. You never see a cup that is both moving left and sitting still. Your reality has a preferred basis. It heavily prefers the basis of position where things are in space.
It's like my macro reality has somehow filtered out all the chaotic, contradictory quantum noise.
But if orthodox RQM traps all your atoms in soundproof booths, they can't coordinate to filter anything.
So Adlam concludes that Ravelli's original framework is fundamentally broken. It cannot explain how I can sit here and drink a cup of coffee without my constituent atoms violently disagreeing on where the cup is.
Right. So she introduces a fix. She modifies the theory to basically provide the sheet music.
Okay, how does she fix it?
Adlam proposes abandoning orthodox RQM for a slightly modified framework she calls RQM plus CPL. CPL stands for cross-perspective links.
Cross-perspective links.
Yeah, it's a relatively small surgical addition to the theory, but it completely changes the dynamics. She adds one crucial postulate. Information can actually be shared between observers.
It breaks the soundproof booths. The violinist can finally hear the flute.
Yes, exactly.
So how does a cross-perspective link actually function mathematically or physically?
The postulate states that if observer Alice measures a system and then observer Bob comes along and interacts with Alice. Specifically, if Bob measures the physical variables in Alice's memory or body that stored her measurement, then Bob's measurement result will dynamically match Alice's original result.
I mean, that sounds so intuitive to a layperson. Of course, if I ask you what you saw, you tell me, we both share the same fact.
But in the extreme relativism of RQM, allowing that kind of objective transfer of data is a massive concession.
Right, because facts were supposed to be strictly isolated.
Exactly. It introduces a systematic physical connection between relative facts. If Bob measures Alice appropriately, he essentially learns her relative fact, and it becomes a fact for him too.
And this single rule allows Adlam to introduce a brilliant mechanical solution to the system combination problem. She calls it informational bonding.
Informational bonding, yes.
I love this concept. Think of a giant party where nobody knows each other. You just have isolated individuals, or micro-observers. But then one person whispers a piece of gossip to the person next to them.
That's a cross-perspective link.
Exactly. Then those two people tell four people. The information cascades. Through these links, the rumor spreads across a specific subset of the party. Adlam is arguing that the partygoers who share that specific rumor have formed an informational bond.
Right.
They stop being isolated individuals and become a cohesive group, a macro-observer, but only regarding the specific piece of information they all share.
That's a really strong way to visualize it. Adlam suggests that a macro-observer isn't defined by drawing an arbitrary spatial circle around a chunk of matter. A macroscopic observer is a composite entity literally forged by the act of informational bonding.
When millions of particles interact and successfully share a relative fact via CPL, they form a composite observer.
And crucially, this composite observer possesses only the facts that its constituent parts share in common.
That only the facts they share in common clause is the magic trick, isn't it? That is how she solves the preferred basis problem and gets rid of the quantum noise.
Exactly, because what happens to all the incompatible facts? If particle A measured a horizontal basis, but particle B measured a vertical basis, they fundamentally cannot share those facts.
They don't have a shared reality to bond over regarding those variables.
Therefore, the higher-level composite macro observer simply never inherits that information. It gets dropped from the macro reality entirely.
Wow. And this theoretical mechanism perfectly aligns with a very real, very well-documented physical process called decoherence, right?
Yes. Let's spend some real time on decoherence because it is the ultimate cosmic filter, and it's essential for understanding why our world looks normal.
Classical physics tells us things are solid. Quantum physics tells us things are waves of probability. Decoherence is the bridge between them.
Decoherence is the process by which a fragile quantum superposition is destroyed by its environment. Imagine a quantum superposition as a perfectly tuned, pristine chord played on a grand piano in a completely silent room.
Okay, I'm picturing it.
The notes resonate together perfectly, their phases are perfectly aligned. That is a quantum system in isolation.
But the real universe is not a silent room.
Far from it. The real universe is a chaotic hurricane of interacting particles, photons from the sun, air molecules bouncing around, thermal radiation. When that pristine quantum system interacts with the environment, it's like a million tiny hammers randomly striking the other keys on the piano.
The environment becomes entangled with the quantum system.
Yes. And because the environment is so massive and complex, the specific, delicate phase relationships of the original chord, the quantum information leaks out into the noise.
You get scrambled.
The information isn't destroyed, but it is dispersed so widely into the environment that it becomes entirely unrecoverable for any local observer. The off-diagonal terms of the density matrix, which is the math that represents the superposition, rapidly decay to zero.
And what you're left with is a classical mixture. The system is forced into a definitive, stable state.
Exactly. And the states that survive this brutal environmental filtering process are almost always states of position, where the object is located.
So Adlam argues that decoherence is the physical engine of informational bonding.
That's her argument. Every single particle in your body is constantly interacting, leaking information, being bombarded by the environment. By the time billions of these particles have engaged in enough informational bonding to theoretically form the you that is listening to this deep dive.
Decoherence has washed out all the weird, contradictory, incompatible quantum facts.
Right. The only facts robust enough to survive the rumor mill of decoherence and actually be shared by all your particles are the stable, classical facts.
That is why your macroscopic reality feels so unified and coherent. You don't perceive the quantum noise because the macro entity that is you is constructed exclusively out of the information that survived the decoherence filter.
It is an incredibly elegant solution, you have to admit.
It really is. We start with absolute quantum chaos particles in a void, isolated in their own realities. They bump into each other, they use cross-protective links to share information, they form informational bonds. The incompatible noise is relentlessly filtered out by environmental decoherence, and boom, you emerge.
A unified macroscopic observer experiencing a single, stable reality.
It feels like Adlam has completely solved the combination problem right there. Like we can just pack it up and go home.
Well, if physics were that easy, we'd have a unified theory of everything by now. The debate never ends. Just as Adlam seems to perfectly map out the solution, our second paper by Timotheus Riedel hits the brakes. Hard.
Riedel is stepping up to defend the honor of Ravelli's original theory, isn't he?
Yes. He approaches Adlam's paper, acknowledges that her informational bonding mechanism is highly elegant, and then argues that it is completely unnecessary.
Unnecessary. Why?
Because he thinks she has fundamentally misunderstood the power of orthodox RQM. He thinks adding CPL is a mistake.
So he thinks Adlam is overcomplicating the mechanics while radically underestimating what the original framework can achieve on its own.
Exactly. He starts by throwing the entire concept of informational bonding out the window. Riedel proposes what he calls the liberal package.
The liberal package. It sounds like a cell phone plan. What are the terms of this package?
The terms are as permissive as possible. Riedel argues that any collection of fundamental particles, no matter where they are or what they are doing, constitutes a valid composite reference system, period.
Any collection?
Any collection. There is no special informational bonding required. You do not need the particles to be interacting. You do not need them to be sharing facts.
So if you draw an arbitrary mathematical boundary around any group of particles in the universe, congratulations, you've just identified a macro observer capable of having relative facts assigned to it.
That's his argument.
Okay, I have to stop right there and push back on this because my brain is rejecting this immediately.
Go for it.
If any random arbitrary collection of particles counts as an observer, doesn't that mean my left shoe, a stray comet in the Oort cloud, and a single star in the Andromeda galaxy collectively form a composite observer?
Yes.
Are you telling me that shoe comet star entity has relative facts? How is that a remotely useful way to do physics? It feels utterly absurd.
It feels absurd to human intuition, yes. But Riedel would challenge you. Why does it feel absurd?
Because my shoe has nothing to do with a star.
Right. But it feels absurd because human beings possess an incredibly strong cognitive bias toward neat, functionally integrated systems. Evolution trained us to look at a cluster of atoms and draw a rigid boundary around it, labeling it a dog or a human or a coffee cup.
We look for spatial proximity and causal interaction, and we call that a system.
Exactly. But from the perspective of fundamental quantum mechanics, the universe does not respect your biological or practical categories.
The universe doesn't have a label maker. It doesn't care that the atoms in my body are physically close to each other.
Dividing the universe into neat functional packages is a pragmatic convenience for our survival, not a fundamental law of physics. We already know from phenomena like quantum entanglement that two particles can act as a single unified system, even if they are separated by billions of light years.
So spatial boundaries don't matter to the math.
To the universe, the atoms in your shoe and the atoms in the Andromeda star are a mathematically valid composite system. They can be perfectly described by a joint quantum state, even if they aren't engaging in meaningful, dynamic joint measurements that we as humans would recognize.
They are, mathematically speaking, a reference system. Okay, if I force myself to detach from human intuition, I can concede that the math of quantum mechanics doesn't care about my feelings regarding my shoe.
It definitely doesn't.
But how does this incredibly loose definition solve the structure combination problem? If I am a composite observer made of billions of atoms, and we aren't using Adlam's informational bonding to filter facts, how do I inherit my macro facts under this liberal package?
Riedel's rule for structure combination is just as wildly permissive as his definition of a system. He dictates that if an external system has a property relative to just one single constituent particle within your composite system, it inherently has that property relative to the whole composite system.
Wait, let me make sure I'm mapping this correctly. If a single photon from a desk lamp bounces off a single atom on my shoulder, measuring its position, that creates a relative fact for that one specific shoulder atom.
Correct.
Are you saying that under Riedel's liberal package, that tiny microscopic fact immediately becomes a relative fact for the entirety of macro?
Yes. The composite system simply inherits the facts of its parts.
But didn't Adlam just spend 20 pages proving that this exact inheritance model creates a logistical nightmare?
He did argue that, yes.
Because if I just blindly inherit all the facts of my atoms, and my atoms are all isolated in orthodox RQM soundproof booths, measuring the universe in totally different, incompatible bases, then I inherit a contradictory mess.
Adlam said orthodox RQM traps observers in isolated realities, yes.
This inheritance model sounds like it plunges us straight into an Everettian many-world scenario, where every particle in my body is branching off into a different reality.
Let's define the Everettian nightmare so we know what we are trying to avoid here. In Hugh Everett's many worlds interpretation, every time a quantum measurement occurs, the universe literally splits.
The wave function never collapses. Reality just branches into parallel, non-communicating universes.
Exactly. If your atoms are constantly making measurements in different bases, and there is no mechanism forcing them to agree, Adlam fears that orthodox RQM essentially devolves into a localized many-world scenario. Your thumb exists in a reality where the cup is on the table, and your pinky exists in a reality where the cup is falling.
And there is no unified you.
Exactly. Yeah.
So how does Riedel's liberal package avoid that exact fate?
This is where Riedel delivers his masterstroke, and it requires a deep philosophical pivot. He argues that Adlam's fear of an isolated Everettian nightmare is based on a fundamental misreading of what orthodox RQM actually claims.
A misreading? How so?
Adlam assumed that because observers are isolated, their facts must be completely unrelated and contradictory. But Riedel says, you are forgetting the most important core tenet of Ravelli's entire theory. Everything is relative, which means which facts obtain relative to Alice is itself a relative fact.
Which facts obtain relative to Alice is itself a relative fact. Okay, that is a dense sentence. Let's break that down layer by layer. What does that actually mean in practice?
It means there's no absolute God's eye view looking down at the universe. Adlam was trying to adopt a perspective from nowhere.
She was looking at Alice's atom A seeing spin up and Alice's atom B seeing spin down and judging that as a contradictory mess.
But Riedel points out that there are no absolute facts about what facts Alice possesses. You cannot assess Alice's internal coherence from a hypothetical absolute void.
So how do you assess it?
You can only assess Alice's facts from the perspective of a distinct third physical observer. Let's introduce him and call him Charlie.
Okay, Charlie enters the lab. Charlie is observing the Alice system and the Bob system.
Right. Charlie could be an external human scientist, or Charlie could just be the ambient environment. This invokes a setup very similar to the famous Wigner's friend thought experiment.
Remind us how that one goes.
Imagine Eugene Wigner, the physicist, is standing outside a closed laboratory. Inside the lab is his friend. His friend opens a box to see if a quantum coin landed heads or tails.
Okay.
From the friend's perspective inside the lab, the coin collapses to heads. He has a relative fact. But from Wigner's perspective outside the closed door, his friend and the coin have just become entangled.
To Wigner, the entire lab is still in a superposition of friend saw heads and friend saw tails.
Exactly. Wigner's reality and his friend's reality are different, but both are valid in their respective reference frames.
So apply this to Rie's Charlie.
When we introduce Charlie looking at Alice's atoms, something magical happens in the mathematics of orthodox RQM. We achieve what is called third-party coherence.
Third-party coherence.
Yes. If Charlie looks at Alice's atom A and Charlie looks at Alice's atom B relative to Charlie, those atoms do have systematically connected facts.
Wait, why? How does the math ensure they don't contradict?
Through the standard mechanics of quantum entanglement and joint probabilities. From Charlie's perspective, before Alice's atoms interact with a particle, they are in a joint state.
Okay.
Once the interaction happens, Charlie's mathematical description of the room dictates that Alice's atoms are now perfectly correlated with the particle.
So Charlie might not know what specific outcome Alice saw yet.
But his math dictates that if he measures atom A and if he measures atom B, their results will be 100% consistent with each other. The contradiction that Adlam was so terrified of simply doesn't exist within Charlie's math.
Because the mathematical laws of quantum mechanics ensure that, from any valid external perspective, Alice's constituent parts are perfectly coherent.
Precisely.
Let me build an analogy to ground this, because this concept of third-party coherence is the linchpin of Riedel's defense. Think about a high-stakes sports game. Baseball.
Okay, play ball.
Imagine Alice and Bob are two umpires standing on a baseball field. Adlam is looking at the umpires and saying, according to orthodox RQM, they are isolated in soundproof booths. They cannot directly compare notes.
Right.
Therefore, umpire Alice might perceive the runner sliding into home as safe, and umpire Bob might perceive the exact same runner as out. It's chaos.
And Riedel's response to that?
Riedel is saying, you are making a mistake by trying to evaluate the game from an omniscient perspective hovering in the sky. You have to look at the game from a specific physical perspective.
Yes, exactly.
So let's look at the field from the perspective of the referee sitting up in the video replay booth.
Yeah.
That referee is Charlie. To the referee in the booth, looking down at the field, umpire Alice and umpire Bob are entangled components of the game.
The rules of the game dictate that they are coordinated.
Right. To the referee, Alice and Bob both called the runner out at the exact same time. The coordination, the agreement between Alice and Bob, doesn't need to happen through them secretly whispering to each other in their booths. The coordination exists intrinsically relative to the booth's perspective.
That is an excellent way to conceptualize it. To the referee in the booth, the umpires are always in perfect sync. Adlam was searching for a new physical mechanism, informational bonding, to force the umpires to agree absolutely.
She wanted to rewrite the rules of quantum mechanics to ensure absolute agreement.
Riedel is pointing out that demanding absolute agreement in a framework built entirely on the premise of relative facts is entirely missing the point of the theory. The cross-perspective links that Adlam wanted to invent already happen naturally, completely for free, within the specific perspective of any third observer.
So Riedel is declaring that orthodox RQM isn't broken at all. It already contains the coherence we need to build a macro world, as long as we rigorously adhere to the rule that we must always define a perspective. Adlam's extra postulate is redundant.
Precisely. From any specific third-party perspective, the billions of atoms inside your body are not a disjointed, contradictory mess of many worlds branching. They are systematically related, strongly correlated entities obeying the standard probabilistic rules of quantum mechanics.
The liberal package, with all its arbitrary boundaries and inherited facts, works perfectly well without spiraling into disaster, provided you stay true to the principle of higher-order relativism.
You must evaluate the composite system relative to an external frame.
Okay, I follow the mathematical defense.
Yeah.
It is incredibly robust.
Eh.
But it opens a door to a massive philosophical problem.
Uh-oh, here we go.
If we accept Riedel's liberal package as the truth, we have to accept that any arbitrary grouping of particles counts as an observer. Let's apply that to human consciousness. The specific cluster of billions of atoms that makes up my brain is an observer.
Yes.
But under the liberal package, the exact same cluster of atoms minus one single atom on the edge of my temporal lobe is also a valid observer, and the cluster minus two atoms is an observer.
That's mathematically true.
Doesn't this mathematically imply that sitting in this chair right now, there are billions of slightly different groupings of particles, all of which legitimately count as Alice? Are there billions of Alice minds all having slightly different conscious experiences right now?
Now we are crossing the border from pure theoretical physics into the philosophy of mind. And this is where Riedel makes a massive, fascinating philosophical pivot in his paper. You are hitting on what is known as the problem of the many Alices.
The many Alices, okay.
And Riedel argues forcefully that the only reason this feels like a problem, the only reason you feel an existential dread about billions of versions of yourself, is because we are holding on to a deeply flawed assumption about what a conscious experience actually is.
I thought experience was just the sum of the facts I perceive. What is the flawed assumption?
Adlam, and frankly many physicists who study foundational quantum mechanics, implicitly assume a sort of informational equivalence. They assume that whatever relative facts exist mathematically relative to a physical system are exactly what that system experiences.
They treat the abstract ledger of relative facts assigned to a macro system as the literal one-to-one definition of that system's perception.
Exactly.
Right.
Yeah.
Like if a photon bounces off a dust mite, and that dust mite bounces off my arm, that physical interaction creates a relative fact for my arm.
Yes, and the assumption is that because the macro-Alice system inherits that relative fact under the liberal package, the Alice mind must somehow consciously experience that dust mite.
Which is crazy. And because there are billions of slightly different macro observers associated with the general boundary of your body.
Each one inheriting slightly different sets of relative facts involving countless dust mites, stray photons, and thermal fluctuations.
You naturally assume there must be billions of Alice minds, each experiencing a slightly different reality. It leads to an absurd overpopulation of consciousnesses, which sounds exhausting, honestly.
It does, but how does Riedel dismantle that? Because he can't change the physics, so he has to change the definition of the mind.
How does he do it?
He takes a strict naturalist approach, grounding the theory back in biology. Riedel argues that it is a philosophical trap to equate the abstract mathematical assignment of relative facts with actual conscious experience.
Oh, I see.
Just because a quantum fact obtains relative to you as a localized physical system does not mean your brain's cognitive architecture processes it. Look at your own daily life.
Like what?
Countless particles are interacting with your skin, your clothes, your retinas every second, creating billions of relative facts, but you don't perceive almost any of them. Your subjective experience is not the invisible cloud of relative facts swirling around your atomic boundaries.
Then what actually generates the experience of sitting in this room?
Riedel argues that experience is strictly tied to your macro-physical bodily state relative to an observer. If you want to know what Alice is currently experiencing, you don't calculate the abstract ledger of relative facts assigned to the Alice system.
You look at the gross physical state of Alice's biological brain and nervous system relative to an external observer like Charlie?
Exactly. The specific macroscopic arrangement of your neurons firing, the chemical states of your synapses, that physical bodily state is what correlates to your mental experience.
Let me synthesize this, because this is a deep paradigm shift for how we view reality. Adlam is approaching this like an IT technician.
Okay.
She thinks human experience is like looking at the digital dashboard of a car. The dashboard displays all the raw data, all the relative facts, the speed, the tire pressure, the engine temperature.
Right.
And she worries that if the boundary of the car is blurry and there are a million slightly different cars generating slightly different data dashboards, there must be a million different drivers perceiving them.
It's an informational view of consciousness, yes.
But Riedel approaches this like a mechanic. He says no. Human experience isn't the abstract data on the digital dashboard. Human experience is the physical engine itself turning over.
Oh, I like that.
The engine is a massive, complex physical object. It can have slightly blurry boundaries. Maybe there's a loose bolt rattling around on the casing. Maybe there's some grease on the outside.
Right.
Whether you include the loose bolt in your definition of the engine or not, it doesn't matter. It doesn't mean there are billions of separate engines driving the car. There is just one massive engine operating in one macroscopic physical state, propelling the car forward.
That is a phenomenal distillation of his argument. The micro-blurriness of the physical boundaries of Alice's body, the debate over which specific carbon atoms are in her boundary and which are out in the air, does not imply a multiplicity of Alice minds.
There's a singular dominant bodily state, and that bodily state corresponds to one experience.
Yes. And crucially, because of that third-party coherence we spent so much time on, to any outside observer, Alice's bodily state is going to look functionally identical, regardless of exactly which peripheral atoms you choose to include in your boundary calculation.
From the perspective of observer Charlie, the dynamical properties of Alice's biological body will be totally consistent. The macroscopic neural firing patterns corresponding to her seeing a red apple will be there, unified and coherent.
Regardless of whether Charlie's mathematical boundary includes the sweat on her skin or not.
What does this mean for us? This redefines not just physics, but consciousness itself.
It's a profound implication for how we view our place in nature. It forces you to consider what actually constitutes your reality. Is your mind just a repository of abstract, informational, quantum facts?
Or is your mind inextricably, physically linked to the state of your flesh and blood relative to the room you were sitting in?
Riedel is suggesting that to truly understand observation and reality, we cannot just look at the raw math of quantum interactions. We must stay firmly grounded in the physical, biological state of the observer. It bridges the massive gap between the sterile math of quantum mechanics and the messy reality of biology.
It's a heavy, satisfying conclusion. So Riedel defends orthodox RQM. He validates his highly permissive liberal package. He solves the many Alice's problem by grounding consciousness in biology. He basically wins the debate, right? RQM is saved.
Not quite.
Wait, what?
Because Riedel is intellectually honest enough to admit that while his view perfectly solves Adlam's specific critiques regarding the combination of facts, his extremely permissive liberal package accidentally opens up a brand new, terrifying sub-problem that Adlam hadn't even considered.
Oh no. What did we miss while we were busy arguing about umpires and engines?
He calls it the final boss of the combination problem. Up until now, our entire conversation has revolved around combining facts. Did atom A see spin up? Did atom B see spin down?
Right.
But quantum mechanics isn't just a historical ledger of facts. It is fundamentally a predictive framework. It's about combining quantum states and calculating probabilities. It's the mathematical machinery we use to predict the future.
Okay, so the new combination problem isn't about what happened. It's about how we calculate what happens next for a macro observer.
Exactly. And the math breaks down in a spectacular way here. Let's set up the paradox clearly. Let's go back to our friends Alice and Bob. They are both in a lab looking at a single particle.
Okay, Alice, Bob, and a particle.
Let's say Bob measures the particle's spin. According to the foundational rules of quantum mechanics, the particle's wave function has now collapsed for Bob. He saw spin up. The probability of that particle being spin up is now 100% relative to Bob.
Right. The die has been cast for him. But Alice is standing on the other side of the room, and she hasn't looked at the particle yet. So strictly relative to Alice, the particle has not collapsed.
It is still in a mathematical superposition. It's a 50-50 probability.
Correct. We have two perfectly valid relative realities. Now, according to Riedel's own liberal package, any grouping of physical systems constitutes a valid composite observer.
9-4, the combined system of Alice plus Bob is a mathematically valid macro observer. So here is the million-dollar question that breaks the math. What is the quantum state of the particle relative to the composite entity Alice plus Bob?
Oh, wow. Yeah, how can a single particle be simultaneously 100% collapsed and 50-50 superimposed for the exact same composite entity?
It's a paradox.
What are the probabilities of their future interactions? If I have a third particle flying through the lab, and I am about to interact with the Alice plus Bob system, what math do I use to predict what happens? Do I treat them as collapsed or superimposed?
It creates a massive mathematical contradiction if you try to evaluate it natively. The standard rules of relational quantum mechanics simply do not tell us how to calculate the quantum state relative to a composite observer when its internal constituent parts violently disagree on whether the wave function has collapsed or not.
How does Riedel even attempt to fix this? Does he just throw his hands up and admit the theory is incomplete?
He doesn't throw his hands up, but he openly admits his solution is highly tentative and requires much more mathematical rigorousness. His mitigation strategy is to lean all the way back on his most powerful tool, higher-order relativism.
Charlie to the rescue again.
Yes, Charlie to the rescue. He says, once again, the paradox only exists because you are trying to view the Alice plus Bob system from nowhere. You must look at it from the perspective of our third observer, Charlie.
How does Charlie see the probabilities? Let's walk through his logic.
Charlie is outside the lab. He watches Bob measure the particle. From Charlie's perspective, he knows Bob interacted with it. So he knows Bob saw a definite outcome, even if Charlie doesn't know what it is yet.
Okay, Charlie knows Bob has effect.
Now, Charlie understands the deterministic laws of quantum evolution. Charlie knows that if Alice walks over and measures the particle later, she must agree with Bob's result, because they are interacting with the same system in the same basis.
Right. They will eventually match up.
Therefore, from Charlie's external perspective, the particle's state relative to Alice is effectively collapsed too, because her future agreement is guaranteed by the math.
Wait, I'm pulling rank as the skeptical undergrad again because that feels like a massive cheat code.
It does feel like one.
You are saying that strictly relative to Alice, she has no idea what the particle is, it's in a superposition. But Charlie essentially says, I know Alice will eventually find out it's collapsed and agree with Bob, so I'm just going to write down my math as if it's already collapsed for the whole composite Alice plus Bob system right now.
You are highlighting the exact friction point. Riedel argues that from Charlie's overarching perspective, the state relative to Alice, the state relative to Bob, and the state relative to the composite Alice plus Bob system are all mathematically identical.
They are all treated as collapsed. The paradox dissolves, but only if you accept Charlie's predictive authority.
Exactly.
It feels like we are sweeping the paradox under Charlie's rug. Reality only makes mathematical sense if we view it through the lens of an external observer who can project how all the relative facts will eventually line up in the future.
It is the bleeding edge of the theory, and Riedel completely concedes it. The actual mathematical formalism of combining probabilities for macroscopic observers, especially when you start introducing self-measurement, where a composite observer measures a part of itself, or complex interference effects.
It's still a largely unsolved puzzle in RQM?
Yes. We do not have a perfectly rigorous, step-by-step mathematical procedure yet to derive the properties of composite systems in every conceivable scenario. The framework is incredibly powerful, but the conversation is far from over.
What an unbelievable intellectual journey. We have covered some serious terrain today. Let's pull all of this together for the listener.
Sounds good.
We started with the radical premise of Ravelli's RQM, that reality isn't absolute, and that every particle is an observer creating its own relative facts. We explored Adlam's combination problem, questioning how a macroscopic world could ever arise from isolated quantum bubbles.
We walk through her solution of informational bonding, the cosmic rumor mill driven by decoherence to filter out quantum noise.
And then we examined Riedel's rigorous defense of the orthodox framework. He stripped away the need for informational bonding, proposing the highly permissive liberal package where any collection of particles counts as a system.
He defended the coherence of this package by relying on higher-order relativism, proving that coherence is found in the perspective of a third party, not in absolute connections. He tackled the many Alice's problem by grounding consciousness in physical biology rather than abstract facts.
And finally, he highlighted the absolute frontier of the debate, the unresolved math of combining quantum states and probabilities. It is a phenomenal ongoing debate that challenges everything we think we know.
It really does.
I want to leave you with a final thought to mull over as you go about your day. If relational quantum mechanics is fundamentally true, if there is absolutely no God's eye view of the universe, no universal absolute GPS grid underneath us all, then every single interaction you have is deeply, physically personal. The very fact that you and I can stand next to each other on a sidewalk, point at the sky, and completely agree that it is blue is not a given. It is nothing short of a macroscopic quantum miracle.
It really is. It is a highly localized agreement forged by billions upon billions of microscopic interactions, filtered relentlessly through the physical states of our biology, and coherent only relative to the shared environment we are standing in.
The next time you look at a friend and agree on what you are seeing, realize you aren't acknowledging some absolute objective truth of the cosmos.
You are just two massive, complex, composite observers whose microscopic relative facts temporarily happen to be singing the same song.
It makes the world feel incredibly fragile, but at the same time profoundly connected. Thank you for joining us for this deep dive into quantum foundations. Keep questioning your relative reality, keep wondering what your atoms are measuring, and we'll see you next time. Turn left at my house.